Cultural expectations of aliens are everywhere. Movies, UFO rumors, and science fiction have made a crowded universe feel like an absolute certainty. But the actual physical scale of the cosmos is far more isolating than those stories suggest. This grid represents our neighborhood, the Milky Way. We are looking at about 200 billion stars. Based on current exoplanet data, we can estimate an average of one habitable planet per star. That results in 200 billion potential environments for life in our galaxy alone. To calculate how many of those planets host intelligent aliens, we need to determine two probabilities: how often life sprouts on a habitable world, and how often that life evolves into a technological species. The problem is, we have no data to determine those percentages. Earth is the only place we have ever observed life. Because our sample size is exactly 1, any scientific estimate regarding the frequency of life elsewhere is a guess. We have never seen an alien, heard a radio signal, or found a verifiable piece of AFLA technology. Must leaves us a scientific dead end, with zero physical ahas and eyes. Since the telescopes haven't provided a physical specimen to study, we have to rely on the only two measurements we can actually verify: the enormous physical size of the galaxy and pound-belly near phase of Vifa. The first logical approach focuses entirely on the volume of space. 200 volume planets is massive. It is large enough to mathematically compensate for even the most unlikely biological odds. Astrophysicist Carl Sagan was one of the prominent proponents of this mathematical viewpoint. If our civilization odds are as low as winning a lottery, 1 on 175 million, you'd have over 1,000 alien civilizations on a galaxy. If odds are lower, trillions of planets in nearby galaxies compensate. Our scientific models rely on Earth not being unique. Believing that life exists only on this one rock requires us to assume a cosmic conspiracy, one where humanity is the only exception in an ocean of identical planets. There is a counterperspective that uses the same math to reach the opposite co-plan. It turns the argument completely on its head by looking at the galaxy as a vast timeline rather than a simple map. The Milky Way is about 10 billion years old. That gives any potential species a massive head start to evolve, develop technology, and spread across the stars. Space expansion is a predictable outcome of technological progress. Humanity is only 200,000 years old, yet we've already sent Voyager probes beyond our solar system. Using our current proportional technology today, we could send probes across the entire Milky Way in roughly 20 million years. 20 million years is a fraction of a percent of the galaxy's history. If intelligent life is common, the Milky Way should be saturated with evidence of their infrastructure or radio signals. This total lack of cosmic evidence was famously highlighted by physicist Enrico Fermi. This is the Fermi Paradox. Because we see no artifacts after billions of years, the odds an intelligent species threaten must be astronomically low. Both arguments rely on logic, yet they reach contradictory conclusions. A third perspective reconciles the math Sagan space of the silent of Fermi's time. As philosopher Nick Bostrom, this theory offers a direct compromise between the two camps. This chart illustrates the great filter. It suggests that while light frequently arises, an evolutionary barrier causes technological civilizations to crash to zero before they can colonize the galaxy. This feature could be natural, like a lethal virus. It could also be self-inflicted, such as a nuclear war or a disaster involving time. This leaves humanity with two possibilities. Are we have already passed this filter for a sequence of miraculous events, or the barrier is still waiting for us in our future? The silence of the night sky assigns different meaning under this theory. The lack of radio chatter represents the residual silence of billions of civilizations that failed to survive the filter. This emptiness suggests two potential paths. Either humanity is a biological miracle that beat the odds, or we are currently moving toward our own inevitable end.